Good morning, everyone, and welcome to the Trilux Academy. Today, I'm really delighted that I'm joined by my colleague, Les Thomas, and together we will go through the WELL Standard version 2, looking at some of the changes to the lighting requirements. But before we start, please can I ask that you type any questions in the chat, and we will answer these at the end of the presentation or in the follow-up email that we will send out in the next couple of days. So to get started, we spend now approximately 90% of our time indoors, and our environment is the biggest influence on our health. That means that our health begins at home, also at work, and in all of the spaces that we frequent on a daily basis. The WELL Building Standard focuses entirely on the health and well-being of the people in this built environment. Now, the WELL Building Institute launched this standard in 2013. The recent update to WELL version 2 allowed other building types, even shell and core, to attain accreditation, and it reduced the barriers to entry and also updated all of the changed criteria. Now, WELL and BREEAM are very much aligning, but there are some differences. BREEAM sets best practice standards for the environmental performance of buildings through design, specification, construction, and operation. Whereas WELL is about the people. It focuses on the human health and wellness. It marries best practice in design and construction with evidence-based medical and scientific research, harnessing on the built environment as a vehicle to support our human health and well-being. It is a voluntary certification and it's utilised in over 50 countries. It's also dynamic, so it's science and evidence-based, a rating system for buildings and communities that enables the characteristics that impact our health and well-being to be identified, measured, and monitored. And I have to state, it is a certification, not a standard. And it places these values on aspects such as lighting, temperature, and even people's mood. WELL is designed to adapt to new research, and it will constantly be upgraded.
Yes, and I was very pleased to see that after the publication of some recommendations for daily light exposure by the Manchester Group, that WELL actually made some tweaks to align with these requirements.
Yeah, they've got these significant findings, and they've been published now, fully published, and it's great that WELL has actually adopted these recommendations into the latest version. It's also using the new metrics that have been published by the CIE as the new SI unit for measuring light that elicits a response in our non-visual system, but we will cover more of that later. So in addition to gaining a WELL at the initial WELL certification, it will be monitored on site to give ongoing verification of the performance of the building. So now WELL version 2 consolidates those previous versions, and the system is still designed to grow over time to adapt to accommodate diverse spaces and geographies and to respond to this new evidence that comes along, and also the ever-growing public health concerns.
And the key principles are based on being equitable, so to provide the greatest benefit to the greatest number of people, making sure it's global, proposing interventions that are feasible, achievable, and relevant throughout the world, being evidence-based, so strong, validated research yielding conclusions that can be accepted by the scientific community, technically robust, drawing upon the best practices of industry and proven strategies, customer-focused, so defining requirements through a dynamic process with multiple opportunities for user engagement, and also resilient, so it responds to advances in scientific knowledge and technology and then is continuously adapting and integrating new findings into the field. I like the flexibility it gives you as well. It's made up of 10 concepts, each with individual features. Of course, for us, light being the most important, some of which are mandatory, so you have to do them. There's also a number of optimizations that you can add to gain more points.
And these points add up to determine which level of certification you will achieve. Really, thankfully, for everybody now, with sustainability being such an important topic, WELL is based upon the United Nations Sustainable Development Goals. There are 17 of these in total.
And it's really nice actually that this ties in with some globally recognised sustainability targets.
Yeah, absolutely. And in this presentation, we will of course be concentrating on light, just the one concept. So each of the WELL features within the lighting concept are based on these UN Sustainability Development Goals.
And generally, the lighting concepts are based upon 4: promoting exposure to light, whether that be daylight or artificial light, and aiming to create lit environments that are optimized for visual, mental, and biological health. And
for me, there are also some really useful notes that explain the background behind each of these requirements. And it includes the needs of our circadian rhythms. So you just dig a bit deeper within the WELL standard, the document, and you can find all these really detailed notes. The WELL lighting concept is actually made up of 8 features in total. And these features are in effect subtopics of light that they want to address. The first 2 are preconditions. These are must-haves. And then features through 4 to 8 are actually fairly straightforward achievements that many projects already adhere to. And they're generally good topics of lighting design, covering elements that most of us are already very conversant with in EN 12464 Part 1.
And these have recently changed a small amount, and the points for each optimization and feature have swapped around a little bit. There's also different, it's also different whether you're working with shell and core or a standard project. So just be careful of that, because there's been a few times when I've been caught out when working on shell and core or standard projects.
The experience is a great thing, isn't it? So yeah, we're going to cover the features in a little bit more detail. And just to guide you through this, the title block defines the point scorings and a brief detail of the content of each feature. But again, the design of this block has changed a little bit.
So the first feature is about fundamental light exposure for people, and previously asked for education so that occupants can seek out the correct exposure for themselves. However, it has now been moved into another section, the precondition for community, where the requirement for a WELL feature guide and to have a quarterly communication detailing the features and aspects that are available.
I think this is great. For me, it's one of the really innovative aspects of WELL, because if we are going to provide the correct light exposure during the day, we need people to understand why we're doing it. And then they will also use this philosophy and carry it on when they go home in the evening, making sure that they're continuing this correct exposure to lighting. So now, light exposure must meet one of 3 requirements, and it's split into regularly occupied spaces and common spaces. Now, spatial daylight autonomy, known as SDA, calculates whether a space really receives enough daylight during standard operating hours, so they consider this to be 8 AM to 6 PM, on an annual basis using hourly illuminance grids on the horizontal work plane.
So now, for regularly occupied spaces, WELL wants an SDA of 200 lux for 40% of the time, and for at least 30% of regularly occupied spaces, or 30% of all workstations are within 6 meters of windows which meet the required level of transmittance, or The glazing area is no less than 7% of the floor area for each level.
And then there's also the requirements for daylight in common spaces. And here they say regular building occupants should have unrestricted access to indoor common spaces with enough space for at least 15% of the regular building occupants at any given time.
And for this, WELL asks for spatial daylight autonomy of 300 lux for 50% of the time is achieved at least 75% of the floor area, or 70% of all seating in the space is within 5 meters, 16 foot, of the transparent envelope glazing with views to the exterior.
Love that, views to the exterior.
Yeah.
And then from the electric lighting point of view, in regular occupied spaces, here we must achieve at least 1 point in feature L03, and this is the circadian lighting design feature. So although L03 is an optimization, here we find it as a partial requirement within a precondition. So they're actually saying this is something that you should try to achieve, even though it's an optimization. Now, feature 2, very early on, brings the focus to the individual needs and the requirement of the task.
It's asking us to consider the age of the user and whether a higher lux level may be required. Also thinking more about than just lighting the horizontal plane, but actually to consider the space as a whole that's being lit. The visual lighting design feature refers to our normal standards, but again highlights some issues. These have always been considered in our lighting standards, but can sometimes often be overlooked. And recently, WELL has updated this to include the latest update of BS EN 12464 Part 1.
Yeah, lots of good stuff in that new update. Now, lighting feature 3, as I said earlier, is our first optimization. And the term circadian lighting refers to lighting applications which focus on human well-being in a very particular way. Awareness of the influence of lighting on health and well-being of people has really increased, and it's developed due to the impact of new and actually very far-reaching findings from intense research activity. There's lots of research going on in this topic. And these findings are leading to a new definition for good light. The human day-night rhythm can be supported by light. And just like daylight, lighting can maintain and promote health and performance capability through changes in light color and intensity. So light has this activating effect, but conversely, at the other end of the day, it contributes to relaxation. And well-being can be enhanced by adjusting the lighting to those individual needs, for example, by changing to warmer light colors. Lighting showcases, accentuates, and creates interesting spaces. So creating a varied light scenario can really inspire emotions. We can feel elated, or we make it all feel nice and cozy, which all enhance our well-being. So circadian lighting, therefore, really has ambitions above purely technical lighting.
And in the new version of feature L03, it deliberately states that this is for day active people and needs to be timed accordingly. 150 equivalent melanopic lux is needed to achieve the 1 point that was referred to earlier in the precondition of feature 1. But for 3 points, we could aim for 275 equivalent melanopic lux. The lighting levels are to be achieved on the vertical plane, not the horizontal, and this is to simulate the light entering the eye. Equivalent melanopic lux was the term that most people were using, but there is now a universal measurement by the CIE in their international standard SO26, which is SI compliant and normalized as melanopic EDI based on the D65 lamp as the baseline.
Yeah, and also this meeting that we mentioned earlier of the Manchester group in 2019 gave some very definite recommendations for MEDI. So greater than 250 MEDI is recommended for daytime. This helps you to remain alert and productive and keeps our circadian rhythms entrained. So now Well has adjusted this to their circadian lighting optimization. And then at the other end of the day, in the evenings, they're saying that for 3 hours before bed, it's recommended that we have less than 10 MEDI, what a mouthful. And there have been a few studies that found this is a fairly typical level in most homes, and it's a comfortable level when relaxing in the evenings. And then, of course, we know that good dark is conducive to good sleep. But if you do have to add light at the night, in the middle of the night, if you need to get up, go to the loo, keep it below 1 MEDI, and then you should be able to go back to sleep fairly easily.
And the Trilux Academy is a separate webinar that explains melanopic lux in more detail. It's a topic that I'll come back to in the future, and I'll show you how to calculate it. But if you have any questions in the meantime, do feel free to contact me. But basically, the fundamentals are intensity, distribution, spectrum, duration, and timing of exposure. There are some basic tables that give us a conversion factor based on the color temperature of the light source, and these are based on the toolbox originated by Professor Rob Lucas.
So now feature 4, and this really brings up that tricky topic of glare. And glare from light sources can really cause discomfort to the user, whether this is natural daylight or artificial light. The effect is the same. So now this Well feature LO4 has changed the UGR from UGR 17 to UGR 16. And for me, this is too easy to say without understanding the consequences. This is a really tight light distribution. And if we put this restriction on the distribution, then we need to add additional measures because we need to light the walls, the ceilings, and the cylindrical requirements for our faces so we can see what people's expressions are saying. By having this very tight restriction on the light distribution, we're beginning to overlook some of the other requirements.
I completely agree with you, Helen. I think UGR 16, trying to achieve it could be counterproductive to a well-lit environment and make achieving some of the kind of recommendations in 12464 and the SLL lighting guides quite difficult to achieve because, as you say, of the tight distribution required.
Yeah, it's going to be interesting to see what happens in the future. Right, moving on to feature 5. This is great. It gives more daylight access than is required in the precondition. So here, if you've got more daylight, you get extra points and therefore you can achieve a higher score. However, there are now new requirements for daylight simulation.
Yes, and it's now a feature in itself, feature LO6. It requires projects to conduct daylight simulation calculations to make informed decisions around fenestration and shading as to provide appropriate daylight exposure for occupants. This could require guidance from daylight professionals at an early stage.
Yeah, and the architect will really need to understand the consequences of their design. And I think this is a great example of requiring the whole team to work together to achieve common goals. And this brings us on to feature 7, which is the visual balance. So this is bringing everything together again, and we need it to give a comfortable space in which to work. Exciting contrasts, overstimulating environments are great, but they really should be left to ancillary spaces where people are not spending quite so much time.
And for most of these requirements, it's actually covered in 12464. So again, good design will cover most of these points in this feature.
Yeah. And also, I think option 2 will please all lighting designers. So they're recommended that you employ a lighting professional. Great. Right, moving on to feature 8. This is the quality of light, which is such an important topic. But it does break into pros and cons. So we're talking about good colour rendering and then the absence of flicker. And to explain this a little bit further, the colour rendering index is commonly used to describe which colours or wavelengths make up the white light that we see. So it tests colours under the proposed light source, and then it compares them to a standard light source. Daylight is the perfect light source, but practicalities mean that we usually use a black body radiator or even an incandescent lamp, depending on the colour temperature of the lamp that we're testing. The standard test only tests 8 colour samples, and these don't include a red, which is a very important colour to us if we think about skin tone. There are an additional 6 colour samples that can be used, and this is in the RA14 version, and it is a little bit better, which is why the second well entry refers to R9. So standard 8 colours don't include red, R9 is a red, so well is asking you for results on this colour sample as well. But we have got some new systems that are being evaluated, and how detailed you need to get will depend on the project that you're working on. But moving forward, I think well asking for this R9 is a step forward. Now we also have TM30, which is a much more detailed metric. It classifies 90 colours using RF, which is a fidelity index, which is very similar to CRI. And then it also uses RG, which is the gamut index, and that provides information about the saturation of the colour. So this is, does it pop, does it stand out, or is it muted? And there is a colour vector graphic, which is a graphical representation of both the hue and the saturation in relevance to the reference light source, which I think is a really useful thing to visually see what you're trying to achieve. Now, on the cons, moving on to flicker.
Yeah, so part 2 covers flicker. We have 2 main types of flicker. Visible flicker, this is the one that we can actually see, and it's the rapid change of the light output from a light source. It's generally reckoned that anything below a frequency of about 90 Hertz can be seen as a physical phenomenon, and it does have health implications. Short-term exposure to between 3 and 70 Hertz are associated with epileptic seizures, with the greatest likelihood occurring between 15 to 20 Hertz. Around 1 in 4,000 people are identified as suffering from photosensitive epilepsy, and there may be many more again who have not yet been formally diagnosed. So this is a serious issue for lighting, especially in large public spaces. And then we have invisible flicker, which is a real problem. However, it's flicker that we can't physically see, but we can all experience it. The symptoms of invisible flicker are familiar to us because they are symptoms associated with sick building syndrome. So the likes of headaches, migraines, feeling dizzy, general malaise, eye strain, impaired visual performance. Although it's suggested that frequencies above 200 Hertz may have a negligible biological effect, the upper frequency limit is not really known. Some people have mooted that perhaps an upper limit of 5.4 kilohertz, but the jury's still out on that, and much more evidence needs to be collected to be certain.
Yeah, we still have a lot to learn on this topic, don't we?
We do.
Now this phenomena is very well known. So this is the occupant lighting control, and occupiers really prefer to have control over their own space. So this feature is very popular.
It's an innovative lighting strategy, including the customization of a user's local environment, and can contribute to the user's satisfaction of the space. Creating zones with lighting conditions that are different from the lighting in regular workspaces can create a comfortable and informal environment that individuals can control for social interaction.
Yeah, they love to have control. But I also love this feature. This is great. it states that supplementary lighting must be supplied upon request and also within 8 weeks. The fact that they put a time limit on this is terrific. The feature also states how the lamp must be positioned, the distance in front of the workstation edge or other work surface, or as per the manufacturer's instructions. And it should be positioned to create minimal visual discomfort for the occupant. So if you need additional lighting, age, your actual visual conditions, you can request additional lighting and it should be provided, which is great.
Yeah, I do like this feature as well. Is a favourite of mine. Looking at the certification process, it's very detailed, and to keep the certification, it must be verified and continued over time. There's a great downloadable checklist. It's a useful tool, not just the lighting concept, but all the concepts within WELL, detailing each feature, who provides the evidence, what testing is required, as well as the points for score.
Yeah, so as you can see, there really is a lot of flexibility built into the standard.
Yes, and if you follow the rules for good lighting design, then you will have already fulfilled a lot of the preconditions. You can see the certification process requires a similar evidence-based approach to BREEAM, but allows for projects to focus on a human-centric design in a way that other certifications do not. It is much more holistic and integral. It is also less of a tick box exercise where credits can be traded against each other. If BREEAM excellent or outstanding is required on a project, then this goes a long way to achieving the precondition credits within the early stages of the WELL certification.
Yeah, and it is a design that is based for people, for individuals. And I personally applaud the aims of WELL, and I also appreciate the conversations that it's inspired.
Yes, it's been great to see the uptake of this approach and the shift in thinking about how the space affects the user. I personally am very excited to see how this develops in the future and where it might take us.
Yeah. So that brings us to the end of this short overview, and thank you very much for joining us. At the moment, I can't see any questions, but if you still want to add some questions, we will respond to them via the follow-up email.
Yeah, and again, thank you from me for joining us today. I look forward to seeing you all at our next webinar, which will be on the Trilux LinkedIn page, but I'll also post it from my personal LinkedIn page so that everyone has an opportunity to sign up for this one.
Oh, actually, there is one question come in. It's the age-old question. What happens in a spec office? How can you use this WELL building standard if you don't actually know who your occupants are going to be?
That's a very good question. A lot of the features will be covered again under 12464 for good design, target lux levels, your good uniformity, etc. When you look at feature 3 for circadian lighting, WELL have actually thought about this, and in their kind of performance guide that you can download for a speculative office where desk space locations aren't known, they recommend you take 4 measurements in the center of your space in the north, east, west, and south directions in the normal way. So have your light meter 1.2 meters above the floor on the vertical. So that's feature 3, how you would go around doing that for a speculative space.
Yeah, it also means that because you won't know the age of your occupants, you won't actually know their full lighting requirements as well. So this is where controls really come into their own once again, always recommending lighting controls as well.
Yeah, or the task lighting option to add in some task lights as well.
Yeah, within 8 weeks.
Yeah.
Okay, well, once again, thank you all for joining us, and we will we'll see you at the next webinar. Thank you and goodbye. Thanks.
Thank you.